Well, good morning, good afternoon, good evening to everyone. Welcome to our next session. This is a mainframe-inclusive DevOps toolchain using BMC and Compuware software. My name's Dave Linsell. I'm a software consultant based in Sydney, Australia, and I help our DB2 customers across the Asia Pacific region to use our products and achieve value from them. I'm joined today by Neil Guilford from Melbourne in Australia. Neil is a ISPW and Topaz software consultant. And I'm also joined by Devanand Karunakaran, who is also based in Melbourne, Australia. And Devanand is a DB2 software consultant. So if we think one of the advantages of joining BMC and Compuware together is that BMC has a strong history in mainframe operations software. Compuware's got a strong history in mainframe development software. So by bringing the two organizations together, we're able to provide a complete end-to-end DevOps solution, including the mainframe, and really focused around the mainframe. So if we look at our agenda for today, we're going to start off with an introduction to what we call the ADE, or Autonomous Digital Enterprise. I'll explain what that is, and I'll explain how DevOps fits into the ADE. We'll talk about some of the challenges that exist today around incorporating the mainframe into your DevOps strategy and the mainframe release process. So some of those challenges. And we'll talk about how a combination of BMC and Compuware software can provide a solution to some of those challenges. Then we'll show you a demo of how this solution works. And I think this is really cool and it's going to be quite exciting. And then we'll talk about some of the benefits to the business of adopting this solution that we're going to present today. So if we move on to the next slide, thank you. So it's BMC's vision that by the year 2025, every successful organization is going to be a software-driven organization and is going to evolve into what we term an autonomous digital enterprise. An autonomous digital enterprise is really based around a set of intelligent, integrated software solutions. We've identified 5 tenets to help customers evolve into an autonomous digital enterprise. And if we look from the bottom, so a data-driven business. Data-driven business means that organizations will capitalize on the data that is generated throughout the value stream to create opportunities for process and product optimization, and generate critical insights. A transcendent customer experience means creating real connections by making technology feel more human and giving employees the tools and software that they need to create better customer experiences. Cybersecurity needs to be top of mind as these transformations take place. Cybersecurity needs to automatically be able to detect and respond to access requests, authentication needs, outside and inside threats, and meet regulatory compliance. As mainframes store most of your critical operational data, the mainframe needs to be a key component of your security posture. Then the next 2 tenets are what we're really going to cover over the rest of this presentation, which is automation everywhere and enterprise DevOps. And if we think about enterprise DevOps and why organizations are adopting them, enterprise DevOps really allows your organization to be more agile and deliver new functionality to your business more rapidly. And that really makes you more competitive in the marketplace. Now, we're going to look at some of the challenges of integrating the mainframe into your DevOps architecture and solution. And to look at some of those challenges, I'm going to hand over to Neil.
Thanks, Dave. So we're going to look now at all of the effort that a developer has to go through to migrate a change into another environment. And let's imagine he's completed development and unit testing of a piece of work, which includes a table change. In this case, adding a column to an existing table, and SQL changes within the program to access the newly added column. So if you imagine this scenario, the first thing the developer will probably do is speak to one of his peers and ask him to review his code and unit test results. If the code passes the review, he'll speak to the PM and ask him about migrating to the next environment in the development lifecycle. If he gets okay, he'll speak to the DBAs to review the SQL. He'll then speak to the source control management team to arrange for source migration to the target environment, the DBAs to arrange for the schema changes to be applied to the target environment, and finally the testing team to perform the testing. At each of these touch points, there is a likelihood that the people the developer needs to work with are busy, and there'll be wait time while they complete current or more urgent tasks before the developer's needs are addressed. It is all this wait time that slows down the developer's velocity and the overall velocity of the project. And I'd just like to make the point here that we're trying to be conservative with the wait time that we can see on the screen now. In IDIG 2021 recently, it was quoted that every time DBA support is required, there's a 56-hour wait time for the DBA to actually action that work. And we can see on the screen now, we've got a value stream mapping at the bottom of the screen, which we built up just, and we can see that there's an activity time of approximately 44 hours, and there's also a wait time of approximately 44 hours. And that wait time is really dead time killing the velocity of the project. But we don't really have to do the work this way anymore. And in the modern world, there is no need for this slow, cumbersome process. Using orchestration tools, we can automate all of the above activities so that the developer can, on demand, perform all of the previous highlighted activities, including quality gates to automatically either promote or regress a developer's changes, depending on where the program passes all the promotion criteria. So that's the scenario that we're looking at today, that point where a developer wishes to promote his changes, having completed his activities. And with that, I'd like to hand over to Devanand to talk about the bigger impacts in the release cycle.
Thanks, Neil. What just Neil explained is a scenario where the developer has finished his activity and he wants to deploy the code in mainframe. And he explained all the delays that can happen. But in real world scenario, this has to happen multiple times before the code is actually deployed into the production. In the modern world, the developer uses modern technology like Eclipse-based developing tools. So he can make the code changes at fast rate. But when it comes to deployment into the mainframes, he is completely relying on the support team. And the priority of support team is not always same as the developer. That causes all the delay. As Dave explained earlier, every organization should be an autonomous digital enterprise by 2025, which means they have to identify all repetitive and manual tasks and try to automate that. Luckily, BMC and Compuware have added a lot of innovation to our products to help our customers reach that autonomous digital stage. Let's look at what solution we can provide for the developer to deploy the code with more independently. As part of BMC AMI and BMC Compuware product integrated in a CI/CD pipeline, you get the developer can now deploy changes into the region in mainframe as a self-service. He can invoke it as a self-service and do the code deployment. And even the testing part, it can be completely automated. Not many accounts have automated testing, but testing is one area that is booming, and we see many accounts are trying to automate the testing, and our solution can deliver that. And even if there is a schema change, the pipeline can have BMC AMI plugged in, and which can do the schema change for without any manual intervention. We do understand still the ownership will remain with the respective support team. As part of this solution, the pipeline can even send out email to the respective team, and this email could be a pre-approval email, which is like the pipeline will stop for the support person to review and give approval to deploy. Or it could be just a post-implementation notification email so that they know what is being deployed in their respective environments. Let's look a bit more detail, like how the pipeline has to be configured. And we will explain each stages in the pipeline in detail here. Through ISPW, the application developer could be using Workbench, where from there he can promote the components. When he promotes, automatically this pipeline can be triggered from there. And when the pipeline is triggered, the first thing that happens is it goes to initialization stage, where it picks up the configuration file which is stored in GitHub or any repository, where the configuration file will have the complete information about the target environment where the deployment has to happen. And then it does the authentication, connects to the mainframe using a user ID and password, make sure that the connection is established and it is authentic connection. And then it also initializes the variables, like it picks up the component name from ISPW. It could be DDL, member name, copybook name, program name, and rest, etc. If there is a DDL component, the first thing it does is it calls AMI compare, which is a plugin that comes with the AMI DevOps for DB2. This talks to the change manager on the mainframe. The first thing it does is it generates a batch job that compares the DDL with the DB2 catalog, and using the batch job, it gets the CDL, which is the change definition language that is needed for deployment. After the change definition language is created, it prepares an execution plan. It does create a work ID, it creates a work list, it creates an execution JCL and an impact report. What you get out of it is you completely remove the expertise needed. Completely, you are relying on DBA to do the schema change. But with this, everything can be automated, and the DBA can just review. If at all there is a change that needs an outage, example, a scenario where the schema change needs a drop and recreate of an object, then you might go for a DBA approval. If it is a simple change, just like adding a new column to a table, which is mostly the cases that changes that happen in the real world, you don't need any DBA review. The pipeline can proceed to deployment stage, where it will take a baseline copy before deploying, and then it executes the execution JCL, which does the deployment with the execution plan in it, whether the alteration needs a drop recreate or it just needs an alter to add a column. It decides whether a reorg is needed, and it even takes an image copy to make sure that the object is available for testing at later stage. When the deployment is completed, again it takes a baseline copy. When the baseline, the schema change is completed, it moves on to the stage where it is called generate rollback, where it prepares the rollback jobs. This is needed if on a worst case scenario, if at all the deployment has to be backed out, you need not get panic anymore. In the real world scenario, it is always panic situation to back out a schema change. But here the jobs are generated and it is readily available with a click of a button, or even you can set automatic schema back out if there is any issue with the pipeline. These three stages, what we saw covers the, let me pick up a pointer so I can explain. These three stages in the pipeline does the schema change, make sure that the schema is deployed without any manual intervention, schema changes, and it even generates the backout jobs needed for backout scenario. If at all it is needed, you can, without any manual intervention, you can achieve that. Now that schema change is completed, we'll move on to the SQL verification part, where it is a plugin called SQL AMI SQL Assurance, which talks to SQL Explorer on the mainframe. And what it does, it picks up all the SQL that has been deployed as part of this change, verifies the access path, and goes and verifies against the rules table whether the standards and rules of that organization standard which you have kept in the rules table is met, and validate all the access path, identify if there is any bad access. Here again, you can configure it to stop the pipeline deployment if there is a bad access, or you can write a report that will write a warning message, send out an automatic email to DBA with the list of violations that SQL access path has been found when the deployment happens. So once the SQL verification is done, we have done the schema change. We have verified the SQL part. Now we'll move on to the testing stage. I'll hand it over to Neil, who is an expert on testing.
Thanks, Devon. So we're at the point where the SQL has been reviewed and the schema changes have been applied to the target environment. And now we're going to start looking at our testing. In the past, a lot of organizations spent a lot of time and a lot of effort building test cases to execute those test cases and then effectively throwing them away and started again. But organizations don't really want to do that anymore. They want to invest that time building up the test cases and have the ability to reuse them then in the future and get value out of that investment in time and effort they put into those test cases. So what we're suggesting here is organizations now start to move to a place where they create the test cases and then they save them in Git. And basically, we're going to extract those test cases out of Git. So we're going to extract the test cases that are actually impacted by the components that we're migrating. We're going to pull them out of Git, and we're going to into the Jenkins pipeline, and we're going to execute those test cases. Now, it's important to note the Compuware solution actually takes those test cases and executes them on the mainframe. So you've got a batch job. There's a batch job that physically executes on the mainframe. If you're an online transaction, it will physically execute under either Kix or IMS. Now, as part of that testing, obviously, we execute lines of code. And as those tests are executed, we actually record those lines of code that are being executed. And in this next step, we actually extract the information. So we extract the lines of code that are executed as part of our test cases. And we do that so that we can feed that information in lines that have executed into our Sonar Cube quality gates. And in this case, we actually defined 3 quality gates for our pipeline. There's one to enforce the enterprise's coding standards, one to ensure that all test cases have been executed and the expected results are the same as the actual results, and finally to review our code coverage. So to ensure that the lines of code that have been executed, so to ensure that we've executed all of the lines of code that have been changed as part of the changes released. With that, I'd like to hand over to Devanand just to talk a little bit about the start of the pipeline again.
What you see on the screen is a pipeline which we created to show a demo of how our products can be integrated. A BMC AMI and BMC Compuware product can be integrated, and you can do an end-to-end automated deployment. Before we actually initiate this pipeline, let me show on the command center what is the DB2 change that is expected to happen. This is the DB2 command center where I'll show the table that is being worked on by the developer for this case. This is a development region table, and the next is the QA table. In development region, if you look, there is 8 columns on this table. What has been done is they have added a new column, whereas in QA you can see it has 7 columns. If I go to the table view, probably you'll get a better picture. This is the table where the developer has added a new column called employee underscore total. When you go and check in the QA table, you will not see this column added. After the deployment, we will come here back and look at this. So back to this, to our pipeline. Yeah, I will ask Neil to initiate this pipeline. How the pipeline is initiated is in the workbench. He picks up the components that need to be promoted as part of this deployment and initiate the pipeline. When it is promoted, automatically this pipeline gets initiated. We'll look at it, Neil.
Thanks, Devanand. So as you can see, we're looking now at the Topaz workbench, which is Compuware's IDE. And that is really a replacement for the old style green screen 3270 emulators that we're all familiar with. And here we're looking at the ISPW perspective within the Topaz workbench, and ISPW is Compuware's source control management. And we can see a program here. Obviously, you've got full GUI interface. You can code through it. You can change the code if you want. You can look to, and you can see the code that we've actually changed down here. We've included some SQL statements. Anyway, so I'll just close that down. So we imagine a scenario where a developer has completed all his activities. He's changed his code programs, he's created a couple of copybooks, maybe changed them, and he's now ready to promote into the next level environment and perform all of the activities that we saw previously. So he's got to have his code review, he's got to get the changes applied, the DB2 changes applied to the target environment, talk to the source control management team to migrate the changes. And rather than doing that, what he's going to do is he's going to select all the elements, he's going to do a right click, and we're going to choose promote. And promote will promote all the full source members into the next level, which is QA1. And behind the scenes, the promote will also trigger a Jenkins pipeline via a webhook to perform all those activities that we saw previously. So I'll just click the promote, and then I'll jump over to the Jenkins pipeline. And this is a Jenkins pipeline that we will trigger in a minute or two. We're actually sitting here now in the Jenkins dashboard, and we just wait for it to trigger. And with that, I'll hand over to Devanand just to talk about the schema changes.
Thanks, Neil. As the components are promoted in ISPW, the pipeline gets automatically initiated. And the initialization state, as I mentioned earlier, it copies the configuration file, which has the detail about the target environment where the deployment has to happen. It also does the authentication, connects to mainframe, and it picks up all the components that has been promoted, like a DDL name, copybook name, program name, DBRM member names, everything it picks up as variable and passed through the pipeline. As there is a DDL component, the first thing it does is it calls AME compare. What does AME compare do? It's a plugin that talks to change manager on mainframe. It picks up the DDL, creates a batch job to compare against the DB2 catalog of the respective target environment. The output of which is a CDL, which is a change definition language. After the change definition language is created, it does analyze, identify the best way to deploy this CDL, and it creates, as part of the deployment, it creates a work ID, a work list with steps that need to be followed for the deployment, and it even prepares an execution JCL and an impact report, which is really useful for DBA to understand how many objects are impacted with this change. Here in this pipeline, you can see DBA approval schema changes there. We do not wait for approval in this case because it's just an adding a column to the table, and it is not a real outage needed change. If there is a drop and recreate, we can capture that using the impact report and make the pipeline to wait for DBA approval. And even this approval need not be for every case. It could be first approval might be done at development to the next deployment, and when it is deployed to the other rest of the regions, it need not be reviewed because it's the same change that is going to be deployed at multiple times. And before production deployment, you can have a change to have a third eye. In this case, as I said, we don't need approval, so automatically it moved on to the next stage, which is deployed DB2 schema change, where it actually takes a baseline copy. It deploys the schema change, the alter statement. It does reorganize the table. It does take an image copy of the table. And then after the deployment is completed, it takes a post baseline copy. When the deployment is completed, it moves on to the next stage where it is a rollback, generate rollback stage, where using the baselines taken, it prepares a rollback job, which can be executed at any time. If at all there is a worst case scenario and you need to back out the schema change, you can instantly do it with a click of a button, or even you can automate it to have an automatic schema backout if at all the pipeline fails at any stage in the deployment. Now that the schema change is completed, it moves on to the next stage, which is AME SQL assurance, which does the SQL check. It is again a plugin, AME SQL assurance. It's a plugin installed on Jenkins, which talks to SQL Explorer on your mainframe. What it does, it explains all the SQL statement that is being modified as part of this change, verifies the access path against the standard rules and standard set in your organization. If there is any violation, it can either stop the pipeline. It again depends on the configuration, how you configure the script on the Jenkins. you can stop the deployment when there is a bad access and ask the deployment to roll back, or you can write it to a report and write out an email to the DBA to take an action. It could be the particular access path needs DBA attention to fix it. It could be a scenario where the DB2 optimizer did not pick the right access path and DBA has to do a fix. Or it could be a scenario where it is a bad job, one-time bad job where you have written a SQL which is not so well picked a good access path, but it could be approved for that deployment. It again depends on the DBA who finally takes a decision. I don't want to jump out from here and show the email because it will disturb the pipeline when we explain. In real world scenario, the DBA would have received an email and he would have verified and he has a link in the email that will bring him to the pipeline. And if he's happy with the deployment, he can just say proceed, which will allow the deployment to proceed. Now that the SQL part is verified, I will hand it over to Neil to explain the testing side what happens.
Thanks, Devon. So as you can see, we're actually now in the phase where we're going to do the testing. And the first thing we do as part of that testing is we connect to Git to look at the repository of test cases, and we extract the test cases that are impacted by the components being migrated or promoted into the next level of the source code system development lifecycle. We then execute those test cases. And it's important to note that the tests are actually executing on the mainframe. So if you've got a batch job, there's actually a batch change. A batch job is actually going to execute on the mainframe. If it's an online transaction, then an online transaction will actually execute under Kix or IMS on the mainframe. Now, as part of these test cases, obviously lines of code are actually physically executing. And we record the lines of executing as the test cases are running. And in that next stage, what we do is we extract that code coverage. So we extract the lines of code that have been executed, so that we can pass them into the final stage of the pipeline, which is a SonarQube quality gates. Now, in this case, we've got 3 quality gates defined: 1 to enforce an enterprise's coding standards, 1 to verify the test cases and verify that the expected results are the same as the actual results that we receive during the execution. And finally, we're going to verify that all of the lines of code that we actually change have executed. If all 3 of these quality gates are satisfied, then the promote will be committed. Otherwise, it will be regressed. With that, I'd just like to hand over to Devon and just to show the results of the table impacts that the pipeline has caused.
Yeah, we'll go to the command center now. We know that the DB2 schema change happened on this table. So I'll go and refresh so that we get the new data refresh from the production. And you see that the column is added. And of course, the reorg has also happened and copy also was taken. So because as part of the testing, we have inserted data into this table and especially into this column as well. Now that we looked at the pipeline, whatever Neil explained in the first slide, he explained in a real world scenario where the things are done manually. It takes around more than a week for completing all this, doing the schema change, verifying the SQL, doing the testing to make sure that whatever is deployed is as per the standard. Everything takes a huge amount of service time, as well as delays is completely avoided when you automate it completely end to end. Now we'll look at the emails that were sent out from this pipeline. I will show the emails. I'm just pulling the email to show. Yeah, this is the first email sent out to the DBA for doing the check on the schema change, where this is the email that they will get. They need not log on to mainframe. They can use the links here and connect to command center. I'm not going to click that link here because it might ask me to log on. So already I've logged on here. So what I'll do, I'll go to the command center and show that screen. So in command center, what it does, the link will bring him to the report where it shows the compare report, where he can click on this object and I see what is the exact change that is happening. That's on the QA table there. There is an alteration to add a new column. So if he reviews and thinks that it's a simple change, he can straight away approve. If at all you are requesting the DBA to approve, or if your configuration you have designed it in a way that if it is a no outage change for a DB2, you can proceed without DBA approval. It would have the pipeline would have continued as we did here. Looking at the second email that is triggered out from this job, it is on the SQL assurance part, where it has a couple of report which can be opened in text format. One is the explain of DB2 packages, which will help the DBA to understand what is the access path that has been picked up. And it also gives another report that is called more important, that is violation report, which shows what all violations or bad access that has been promoted as part of this deployment. It can be opened in a text format and viewed, or he can use this link to click, which will take him to the command center. Here I'll show the command center. The command center on the production tool, it will come to this link where he can see actually what is being deployed and what is the violation that has been reported. There is one violation here, which is if you want to see the details, you can click this properties where you can go and see the actual SQL. It was coded as select star. Normal coding standard doesn't allow select star to be coded. As you all know, if DBA specifically know what is the reason we don't allow select star. And it gives clear information like what is the violation and what is the reason. It can be read from here. For every violation, you have an option either to say that for this deployment, I am allowing this to proceed. You can say ignore violation, or when you say ignore violation, it adds this violation into the rules table, which means that next time somebody promotes this, they know that this is already reviewed by DBA and this bad access has been already approved. I won't say bad access, this particular access path, which is not standard, but it has been already approved by DBA for some reason. It could be one-time job that they want to run. So every time that access path is chosen, you need not wait for need not write and ignore a violation rule. So going back to the pipeline, I'll go to the demo. Here, whatever we saw in this pipeline is completely customizable or tailor-fitted as per the organization need. There could be a account where they need automation of testing alone. Yes, it is possible. We can just create a plugin pipeline with just the testing components to do the testing alone. So every time you need to do a testing, you can call that pipeline through either from the Jenkins itself, you can trigger it, or through other means. Similarly, you can have pipelines for just SQL schema change or DB2 schema change or SQL verification. And this pipeline can have more components, stages as well. I'll give an example where you want to take a baseline of data before the testing starts. What you can do, you can have a stage introduced here to run a image copy and a queries on the DB2 subsystem before the testing commences. And you can have a stage at the end to restore the data back to the queries point, so that whenever you want to do a rigorous testing, you need not worry, even that is completely automated. So what you can achieve out of the CI/CD pipeline of Jenkins is you can do everything. It's up to your end organization what all automation you have to do, you can do. But we recommend the target should be to have an end-to-end automation so that you can move towards an autonomous digital enterprise stage. Now that we have seen this, I will hand it over to Neil to explain the business values that you get out of this.
Thanks, Dev. So today we've shown you a sample BMC and Compuware integrated mainframe DevOps solution, triggering pipelines automatically from a source control management action, and in this way significantly speeding up the deployment process, both from the perspective of time spent on activities and elapsed time. We're going to think now about why enterprises should want to adopt modern delivery practices. Well, we live in a world where change and innovation is constant. Businesses need change, and innovation at speed is the only way to satisfy these business needs. Legacy waterfall delivery processes were never intended to deliver at the speed required of the modern world we live in. So in order for mainframes to remain relevant in the current times, development teams need to adopt agile delivery processes. continuing delivering small iterations of new functionality into production, dynamically adapting future requirements and deliverables as functionality is delivered. When enterprises embrace agility, embrace automation, embrace collaboration, and work together to deliver the functionality that enterprises require, enterprises are able to reduce their time to market significantly. And why should that be important to an enterprise? Well, simply put, competitive advantage, the ability to deliver new functionality before your competitors. If people want what you have and no one else has it, well, that's a great place to be for an organisation. Modern delivery practices also help maintain stability and provide high levels of availability by using repeatable processes to deploy changes. Ongoing reuse, feedback loops, and continuous improvement build up the process until it is dependable and reliable. Deployments become painless and run-of-the-mill. Additionally, as we saw earlier today, modern deployment processes incorporating automation eliminate wait times while significantly reducing service times. And obviously this reduces deployment times and increasing that all-important system availability. Stability is improved due to the ability of automated testing to significantly increase the number of test cases executed against changes, ensuring new features are far better tested than they ever could be before, especially helping in testing for regression type impacts, which in my experience are the most likely causes of production issues. Additionally, modern delivery practices focus on delivering small, bite-sized chunks of functionality. When problems do occur, identification and resolution becomes far simpler. And obviously simpler, easier resolution leads to shorter outages and better stability. And what about reduced cost, effort and expertise? Well, I believe that from what we've shown you today, it's obvious that the type of automation demonstrated reduces cost and effort. Today, we saw a real-world sample scenario where a developer wishes to promote code into a test environment and reduce elapsed time from days to hours or even minutes. The pipelines also help to reduce the levels of expertise and knowledge required. If organizers invest the time and effort of building up comprehensive test cases and pipelines, there are reduced dependencies on experts during testing and deployments. In effect, modern practices allow knowledge and expertise to be coded into pipelines and test cases. And with that said, that's all we have for today. I hope everyone has found the presentation interesting and we've piqued people's interest in mainframe modernisation. If you do want to speak to us further about mainframe modernisation or anything that we've seen today, feel free to reach out to us.